Hi, this is Shannon Seaver, and today we're looking at section 3.6, determining the validity of arguments. So, we're going to determine the validity of an argument by using a truth table today. First of all, I would like to give a definition of what a valid argument is. An argument is valid if the conclusion is true whenever the premises are assumed to be true. An argument consists of two parts: the given statement, the premises, and the conclusion. Now, one thing you do need to know is that an argument is not valid is called an invalid argument, which makes sense, but it's also a fallacy. So those are some things that you probably should write down as definitions in your notebook. So here's an example of an argument. The first premise is, if you come to the game without a ticket, then Seaver doesn't let you in the gate. So if you notice, that's a if P then Q type of statement. Premise 2 is, you came to the game without a ticket. And then the conclusion was, therefore, Seaver doesn't let you in the gate. Notice that the three dots on the side there, right here, that is considered read as therefore. So, how do we take this and determine how an argument is valid or not? Well, first of all, you need to express the premises and conclusions symbolically, like we have here. Once you do that, you can rewrite it as a conditional statement that has the following form: if premise 1 and premise 2 and premise 3 and so on, then conclusion. So here we only have two premises, so I have them listed here separately within brackets with an and in between them. Now, if I had three premises, I would have all three of them within the square brackets with and in between them. And then I have an if-then conditional operation and then Q. So now that I've made it in symbolic form, I need to create a truth table for the above conditional statement. If the final column is a tautology, if they're all true, then the argument is valid. So what we're going to want to do now is actually make a table for this. Here I have already placed in the headings of my table all the things that I need. So let's go through and actually calculate this to see if it is valid. Notice that I have P then Q first. Remember, if it's an if-then statement, we have to have first a true, then a false, and we have one of those right here. In order for that to be false, everything else is true. Now we are doing an and statement. We're going to put that together with a P. So there's only one place where we have two sets of trues to make a true, and everything else will be false. Remember, for an and, you have to have two trues to make a true. Now we want to look at this with Q, and I'm just going to squeeze Q on right here just because I want to make sure it's in order. So remember, with an if-then statement, we have to have first a true, then a false. And notice that we don't have any of that here. So all of these will be true. Because this is a tautology, this argument is valid. Let's look at another one. This one is Spock's logic, and this came from one of the movies Blitzer was looking at in the textbook. Mr. Spock's reply to Captain Kirk's question about if Mr. Scott is aware of the power being off is, if Mr. Scott is still with us, the power should be on momentarily. So we need to write this into our premises and in our conclusion. So our first premise would be, if Mr. Scott is still with us, then the power will come on. So we have P then Q. The power comes on. Here we have Q, therefore Mr. Scott is still with us. So after having it in this form, notice that I have each premise with an and in between them inside the boxed area here. And then we have a then and then the conclusion. So we have our conditional here that we can actually check on a truth table, and let's do that now. Here's the Spock logic truth table. We have P then Q. So we are once again looking for a true then a false to make a false, and everything else here would be true. We have an and statement, and this time we're combining this column with this column right here. We're looking for two truths. We have one right here. That's going to be a true. And we have another one actually, and that's right here. And that will be a true. Everything else will be a false. Now we need to have if this column, then P. And I'm going to just squeeze P in over here, just so we have the right order. And we need to find a true and then a false to make a false. And look, we have one right here, a false. But notice everything else is a true in that column. So based on this, this is not a tautology. And because of that, this is not valid. So we've always thought of Spock as being very logical, but in this case, he's not being logical. Now, if we have a three-statement argument, we're still doing the same kind of thing. But instead of just P and Q, we might have a P, Q, and an R column in this. Let's look at this one. We have first premise is, if you lower the fat in your diet, you lower your cholesterol. The second premise is, if you lower your cholesterol, you reduce the risk of heart disease. And last, the conclusion. Therefore, if you do not lower the fat in your diet, you do not reduce the risk of heart disease. I challenge you to pause the video right now and to try to come up with the statements that go to premise 1, premise 2, and the conclusion in symbolic form. And then I challenge you to also try to come up with the final conclusion, not the final conclusion, but the final conditional that you would use for your truth table. Hopefully you got this. P then Q. So this first statement's our P, the second one's our Q. Then we're going to use that same second statement as the first part in our next one. And then we have lastly R, you reduce the risk of heart disease. And notice that we have our therefore. If you do not lower the fat in your diet, so that's going to be a negative P, then not R. So we need now to make our conditional statement. And remember that we are going to put each of these inside the brackets with an and in between them. Here's what you should have gotten. Bracket, P then Q, and Q then R. And then you see the bracket here. Then not P, then R, not R. So we're going to take that and put it into our truth table on the next page. Now that we have this in our truth table, we need to figure out our values here. Now would be a good time to maybe pause the video again and practice on the truth table, and then come back and check and see if you got the same answer. If not, just follow along. So we have P then Q. So we're looking for a true and a false in the P and the Q columns, and we have two right here. So a false and a false. Everything else here will be true. Now we need to look in the Q and the R columns. We have a true and a false here, and another one right here. Everything else in these two columns will be true. And finally, we need to look at a P, not P and a not R. Notice that I neglected to have a not P and a not R. So I need to go ahead and kind of make this into three columns here. So this will be our not P, not R, and then we'll have that conditional be in the final column. So our not P column is going to be false, 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 true, 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 true. Our not R would be the opposite of our R column, so it'll be false, true, false, true, false, true, false, true. And then the if-then statement. Once again, we're looking for first a true, then a false. We have one right here and one right here. Everything else will be true here. Okay, so Notice that I did not make a column for this. We need that column, so I'm going to make that here. So that's the P, then Q, and Q, then R. That's going here. And then this final column is all this. Okay? So we're looking at this column here and this column here. And we're looking at an AND statement. So that being the case, we're looking for two trues. Here's one there. And there's one right here. And two of them right here. Everything else will be false. Now, be careful when you're looking at this if-then statement for the final column, because my two columns are switched, so you need to look at it backwards. Unless I wanted to rewrite this on the side to make sure I have them in order. So what I think I'm going to do, just to be safe, is I'm going to change my ink color here, and I'm going to write this whole column right next to it, just so that I can make sure that I have it in the correct order. And now I can look at the true and false, finding those, and this is a false here. We have a false here. Everything else is a true. So, a valid argument. What is a valid argument? Well, a valid argument is when you have two premises or more. They are connected by ands, and they are turned into a conditional statement where you have them together, then the conclusion. And we can look at those in a truth table, and if the final column is all true, then that argument is valid. That is it for today.